Welcome to Learn and Create Code. Today we are on challenge number 16, and today we are to create a function that will return a boolean specifying if a number is a prime number. So what is a boolean? A boolean is a data type that returns either true or false. So these are the two that we have under the boolean type. And what is a prime number? A prime number is a number that can only be is only divisible by 1 and itself. So these are some of the numbers that we have, and so on and so on. I believe the one is under debate. I think one, I'm not sure. I think it's under debate there. So we're just gonna start at 2 going onwards there. So what it will do, it will take the function that I'm going to create. It's going to be check num, and it will take in a number with it when it's called. Then what we want the function to do is now it will check that number that it has taken and to see if that number is a prime number or not. So before I check the other numbers, if the number that's put in there, if num is less than or equal to 1, let's just put that there like that. Since this one, we're just gonna return false here. If that number that they give us is less than or equal to 1, I'm just going to return false with this one. So let's put in there, and we will write return false. Return false. Then like that. Then the second one that we're going to do is check if, so let's, before we go to add numbers, let's put 2 in as well, because the method that I want to use, it won't work with true. So it will check if the number is less than or equal to 1 and return false, and if the number that we put in is 2, it will return true, because 2 is a a prime number. Sorry. So if num is, I think it's equal, let's put it like that, equal to 2, I think it's like this. Is it true? I'll check and see if that's true there. Then I'm going to return, it's going to return true. Yeah. Over there, right? Then now let's just try, and I think it's always 3. Something. Oh, okay. I think I see what's up there. And vectors. This is where we're supposed to have the closing bracket over there, not here, over there, and then here it's equal to that. Yes. So return false. So let's just try it out with, let's just call it function check num and put in true. Just want to see if it works. There. Check num true function. So let's not put the function, just gonna call the function over there. Control save, and let's run it and see. We're not getting anything back. Why aren't we getting anything back there? Let me. Okay, let's check with 1. Let's. Oh, sorry. Let me save this. Control save, and let's run that. Still get nothing there. Console.log. And let's run it there. Let's save that, let's clear that, and let's run that. Yes, it just gives us false for 1. Let's check for 2. Confusion here. Supposed to put the console.log in there. Control save, clear that, let's run it there. It's true. So this works. Now what am I going to do? Let's see how we're going to check. How can you check if 5, if 3, is 7, or is 11 is a prime number? Okay, we can divide it by numbers that are less than it. Like for 13, let's take in 13 for example. We're going to try to check if one it's two. If two is a factor, can 13 be divided by 2 without leaving a remainder? Can 4 be divided by Can 13 be divided by 4? Can 13 be divided by 5, 6, 7, 8, and until we get to 13 until we get to 12, sorry, without leaving a remainder? Well, that is one way we can do it, right? But if we think about it, let's say if the number is as our numbers progress, they're becoming bigger, quite bigger, like 100, not 150, sorry, like other numbers. Another big number that we might have there might be an x. Let's just put x number there. How can we do it without having, is there a way that we can reduce the number of iterations that we have to go through? And if we know something about factors, let's check. Let's use the number 16. Which factors? The factors of 16 that we have 2, we have 4, we have 8 over there. We know 4 we have to multiply. We have to multiply 4 by itself. It has to be 4 by 4. Then 2 has to be multiplied by 6. So if 2 goes into, 8 over here, sorry. If 16 divided by 2 is going to be equal to 8. 8 into 16 is going to be equal to 2. So over here, if we already find out that 2 can get into 16, it means that 8 can get into 16. So we can actually stop when we get to 4 and not check 8 as we go on, because we already know that since 2 goes into 16, there's an 8 there coming there. So that's the same thing we can do. We will take the square root of a number. 4 is the square root of 16. So let's go to another one. Let's just give another example there. We can go to 25. We'll check the square root of 25. Its square root of 25 is 5. We'll check numbers less than 5. We can start from 2 to 4, and we'll check if 25 modulo those numbers is giving us a 0. If it gives us a 0, that means it does have, it's a factor of that number, and it's not a prime number. But if it doesn't give us a 0, let's say it gives us a 5, a remainder, something that shows that that number cannot be divisible by any of these numbers, and that will be the one that we're looking for. I hope that makes sense, because I was trying to go through this. I was trying to figure out a way to make it make sense, right? Okay, so I just wanted to explain that a little bit better. So for example, let's say we have a number 256 over here, and 256, its factors are these ones. These are the factors of 256. So this means that 256 is not a prime number because there's all these factors. So this is a method that you can use to test out our numbers to see if they have factors or not, if they're prime numbers or not. So we check for the square root of this number. For example, here it's 16. Instead of trying out from I is equal to 1 to I is 256 to see if it has factors, we can use the numbers that are to the left of the square root. Why? Because we know that if we say 256 divided by 1, we'll get 256. If we say 256 divided by 2, we'll get 128. If we say 256 divided by 4, we'll get 64. If we say 258 divided by 8, we'll get 32. So that means that if we determine that these numbers get into 256, we won't need to try out these numbers over here. That's what it means, because these numbers, we'll get these numbers from trying out these numbers over here. So we just have to try out numbers that are to the left of that number square root. So for numbers like, let's look at 17 over there. The square root, I have to punch it out. Square root of, let me say square root of 17 on my calculator here. Square root of 17, I'll get a 4.1, 4.123. So this is how I'm going to test it. I'm going to say my I limit is going to be 4. So I will start at I is equal to 2 because I is equal to 1. Every number can be divided by 1. So we'll start with I is equal to 2. 2 into, we'll check if 17 can get into 2. If not, okay, we move to the next one. 3, can 3 get into 17? No. Can 4 is the last number we try out, can 4 get into 17? No. Then we can actually determine that no number can get into 17. Then we now know that 17 is a prime number. So this is how we're going to be doing it for all our numbers. So this is the method that we will use. So for numbers like 17, this one is a prime. 256 is not a prime number. So yes. So we're going to, so if it passes these two, we're going to go through a for loop. For I, or variable I, is equal to 2, I is less than or equal to, let's just say it's less than, okay, less than or equal to the square root of that number. And for the square root of that number, we have to introduce a variable there. Let's just call the, so here we're just gonna call var, let's just say square root num is equal to, so to get the square root we use math dot sqrt num over there. Yes, then it has to be less than this sqrt, less than or equal to that. Then after each iteration, increases by 1. Plus there. Then what do we do? And then we now work it out using this, the modulo now. So it's now num modulo I let's say now we're checking number 3. This one, it fails because it doesn't satisfy this condition, so it now goes through this. We now find the square root of 3. Then when we find the square root of 3 over here, square root of 3, for 3 I think it won't work over here, but for 4 it will work, right? For 4 it will work, but for 3 it might not work over there. So it's fine, we'll figure it out after we are done. But let's say for 4 it will now say math square root of 4 will get 2. Then from I is equal to 2, then it will just try it out and see if 4 can be divided by 2. Then it will see that yeah, 4 can be divided by 2, so then it will return a false. Now divided by I is equal to 0. So it's going to check if this is true. So it's going to be if num, then it's going to return, if num, it's going to return false over there, return false. Otherwise it will return, if num, it will return a true, there. So let's control save that, let's clear that. So this is the function that we have over there. So let's try it with 4. Control S, let's run that. False. Okay, let's try it with 5. Ooh, 5 it's false, but 5 is true. Let's check it, and see if everything is working correct there. So Yes, so over here, there is a slight mistake. This return true value should not be over here after the if, because we want it, if the number is not a prime, it should return a false. If it is a prime, it just skips over it and goes to check with the next I. So this return true over here only comes in after it has checked all of the values and it has seen that all of these were not giving false, and then it will come and return true over here. So now you can now come in and check with the values that we have over there. So I'm just gonna start with, let's start with 4 over there. Control S, let's run this. Is 4 a prime? False. Is 7 a prime? True. Is 16 a prime? False. Okay, let's check with other numbers. Is 15 a prime? False. Is 67 a prime? True. Okay, now let's try. So the number that we didn't try was 3 over there. Because over here, I think it will contradict. If we put a 3 in there, square root of 3. And let's just say square root of, let me just punch it in the calculator. Square root of 3. Square root of 3 is 1.7. So let's see if it will work with 3. If it doesn't work with 3, I think we have to define 3 over here for itself and just say if it's 3 or 2, we give it prime. Let's just put 3 there. Control save and run it there. True. 3 is a prime, so it works with 2. I thought it would say no over here, so I think I'll just have to go and read through the documentation again and just see how this works over here. Thank you. Bye.